Yeah, we're getting close to perfect. Yep. Sorry for the interruption. Yeah, so when you put together any new complicated system, you look at other things that exist and try to pick the best ideas and make them work together somehow, which was the biggest challenge. And it was never a goal to invent new things with Kotlin. We ended up inventing some things, but the spirit of the project was not research, but a production language. So this is what we did. And I would like to say thank you to all the languages we learned from. Contrary to the common spirit on the internet, where people are fighting over like which language invented what and like which one is more original and all that. Interestingly enough, actual language designers, at least successful language designers, never fight about these things. So this is completely on the user side and never on the side of people doing the actual work. So yeah, 3 simple things I want to convey today. Originality is not your goal unless you're doing art, which we aren't. Building on top of other people's ideas is a good thing. You should do it. Use my ideas if you like them. And giving credit is a good thing too, and I'll be doing it today. So Kotlin was designed from the start under the motto of a pragmatic language for industry, where pragmatic means that we do what's practical, not necessarily super elegant. So elegance is secondary. It's still good because elegant things are easy to learn. But elegance was never the goal. The goal was pragmatic usefulness. And industry is also a keyword here because we targeted large teams, large code bases, long periods of time, so actual industrial setting. And this affected the design quite a bit. So what do you think? What languages did Kotlin learn from? Java, Scala, C#, F#, interesting. Python, okay. So what do you think? What language influenced Kotlin the most? Okay. Swift. I have a slide for you. Okay, so in my personal opinion, Java influenced Kotlin far more than any other language, but Scala was also a big influence, and there were a few more. So let's play this game that people play on the internet quite a lot. They say like Kotlin is just Scala without all the nice things, or it's just this and that. So what language is this? Java would work. C++ would work. JavaScript would work. Yeah. Any other options? C# would work, and Kotlin would work as well. So Kotlin is just Java without, I don't know, all the boilerplate maybe or something. Another question, what language is this? Kotlin, any other options? Scala, other options? No, these are actually the only 2 options. It's either Kotlin or Scala. So Kotlin is just Scala without all the crazy stuff, I don't know. This, what language is this? Kotlin is a good point. You get the idea. Yeah. JavaScript, no, you can't do this in JavaScript. Yeah, Kotlin is already there. Groovy, correct. So this is either Groovy or Kotlin. So Kotlin is just Groovy without all the, I don't know, all the mess. And this. C++. Let me see. I'm not sure. Didn't do exactly this in C++? Probably, yes. C#, good point. And Kotlin. So Kotlin is just C# without all the Microsoft or something. Yeah, so you can see that there are many languages that influenced Kotlin syntax quite a bit, so that bits of Kotlin actually compile in other languages. Yeah, but we'll go a little deeper than that. So these are the biggest influences. So Java and Scala were very big influences. Java mostly through the runtime and the libraries, Scala through the syntax and many interesting inventions on the JVM, Groovy as well, pioneering lots of things on the JVM, C# being a great language in a somewhat related runtime, not quite the same, but there are many similarities, and Python being a very elegant scripting language everybody likes to learn from. There are a few others that we'll learn from, not so much as from these ones. I'll show these as we go. So this slide is complicated. It's a timeline. So at the top, I have years. Oh, I don't want this picture here. Can I get rid of it? Yeah, probably not entirely, but yeah. So we'll sacrifice this version of Scala. Oh no, it's not working. Forget about it. So in any case, the timeline goes from 2010 to actually 2016, when the first version of Kotlin was released. And here are all the versions of other languages that were actual at the time. So Swift was being worked on, but kept secret until 2014, where it was already too late to learn from it. So we unfortunately couldn't learn much from Swift. I would love to, but I didn't have access to it. Other languages, you see, the most important context here would be Java. So Java was Java 6, 7, and by the end of the development cycle, Java 8, which means this is super outdated by this point. So Java 6 for year 2012, or Java 7 is essentially the same language. There are almost no language changes. It's a very outdated language. So C# was far more advanced by this point, and people on the JVM were really unhappy about that. So Kotlin was targeted at those unhappy people. When Java 8 shipped, it was a big improvement, but still Kotlin was relevant to many use cases, and as it is till today. So Scala was a version 2. All the new shiny stuff didn't happen then. Groovy was this transition from 1 to 2, and and Python is always both 2 and 3, but 3 existed at the time already. Any questions about this? Okay. So let's talk about, so this is just the title slide. Let's talk about the syntax. The syntax, I mean something that's done by the parser, something that everybody understands, so everybody has an opinion about. And it was quite a big fraction of my time talking to people in the beginning of Kotlin, when everybody had an opinion on where you should put the types on the left or on the right. Is it good to not have semicolons or other things like this? So I'll give you a glimpse of how we looked at it. So we tried to first remove crazy stuff from Java that was legacy, because over time people just figured out that some things from C weren't so great, and like this kind of loop, nobody actually needs it. We just don't have it. We should have actually had a ternary operator, but we didn't include it, and no assignment expressions, bit shift operators, again, not used so much, so we just replace them with functions, so on and so forth. So this thing is obviously just dangerous because you can assign as a byproduct of a condition or something else. This thing is very cumbersome, lots of boilerplate. It's super flexible, but you don't really need it. And some other things that are just not used enough to have specialized operators. Okay, and I'm disconnected apparently. Am I? Yeah, I don't know what's going on with this. Ouch. So, no internet again. For reasons unknown. Let me try again. Any questions about the syntax while we are waiting for internet? Did we get something? Yeah, I'll have to reshare my screen. All right. Okay, now a little more about the syntax. So Kotlin got rid of all the semicolons, but semicolons exist for a reason, right? So semicolon is there to break the line for you. Fortunately, you have a special key on your keyboard for breaking the lines. So the parser can actually understand that a line break here is good enough, that the line break here is not important enough, but the one here is, and even a line break here is okay, and the expression continues to here. You can't do everything like this, so there are exceptions, and this rule that comes from Scala, and we happily used it, says that, okay, if you break your line in front of a plus, sorry, you now have two expressions, A assigned to A and a plus B as a separate thing. So this is the entire price we had to pay for the absence of semicolons. Great idea coming from Scala, worked well for them, we just took it. And by the way, it's smart enough to understand that inside the parentheses, all this craziness doesn't happen. So this way you just jump into the 21st century, easily getting rid of all the semicolons. Of course, Scala wasn't the first language that got rid of them, but they have probably the cleanest solution because JavaScript, for example, has some common mistakes associated with that. Okay. It's going to be a challenge indeed for us, folks. Yeah. Yeah, so Scala's solution is the cleanest. Another thing, so how do you declare variables and properties and classes and so on and so forth? And this was a huge debate. So everybody, all our users were coming from the Java background. So they were used to types on the left. So you say int x, which is so nice in English, right? And we wanted to say val typed :int. And everybody was, oh no, this kind of language can never fly. They were like, okay, yeah, sure. But it's so much nicer if you want to omit types. Like you can drop the type and the syntax just flows. And of course, today's Java and C# have to use this same syntax because they have to put something in the place of a type on the left when they infer it, right? So yeah, we went after Scala's solution to this more or less, and it was validated already. We were pretty sure it will work. But also, we didn't want, oh my God, we didn't want Scala's word for defining functions because Scala has a def, like Python, have def, and this doesn't make much sense because oftentimes things starting with def are not definitions, they're declarations. So we wanted to say it's a function because it's a function, but then we wanted also to align the declarations nicely with three-letter words. There are guys speaking English here. Three-letter words are big in Russian. And yeah, so we were on the team, we didn't have native speakers of English. And we were like, is it okay if we have a proper English noun here? And of course, with other keywords, you can have in Kotlin like a private fun, for example, or public fun, or you can expect fun, or you can have actual public fun. And we're not at all sure it was okay. So we were looking for a precedent in other languages, and we found one. Do you know any language that uses fun for functions? So many people say function, which is very long. Some people say FN, which is a company making guns. Some people say funk, But there are actually languages that say fun. Unfortunately, say it again? Elixir, I'm not sure, actually. It actually came about later than we started. The good thing, at least one of those languages was made by an Englishman. So we're sure it was okay. The guy's name is Robin Milner. The language name is ML. It's a very famous academic language, one of the first pure functional languages. And fortunately, there they have fun. So we were safe with Robin Milner's blessing. And yeah, and all the jokes, of course, happen. People have private fun in Kotlin all the time, and we're happy about that. And my internet keeps crashing. I don't know why. I wonder, do we have an alternative network here? Because I keep getting disconnected and it will be annoying. Do you think we have anything else? Okay, thank you. Problem is I don't see you here. Let me retry. Sorry, we'll try it. Actually, there was an interesting. You know? Don't know. Okay. Oh, great. Thank you so much. Yeah. Okay. You're my hero. Thank you so much. Yeah. I'm not sure what happens if you walk away with that. Yeah. You totally need to plug it in. Okay. Yeah. Thank you so much. Okay. Yeah. So we're back online. Actually, there was a similar situation once. We held the first Kotlin Conf in San Francisco. It was like 700 people in the room. At the keynote, Wi-Fi just went out, and we were doing a live demo of something that was connected, and like the guy doing the demo was trying to do something about it, and it was not working. And I was already rushing upstage to like fill in for him and do something else. And then he just literally pulls out his phone from his pocket and connects, and it works. And it was like an ovation. Because yeah, so he actually saved the day. And that was like the first Kotlin Conf. It was the worst in terms of logistical trouble. There was some CO2 sensor went off at the keynote backstage. So it was beeping like through the entire keynote and all that. So yeah, I'm a little bit used to these things. Any questions about Velvar and fun? Okay, yeah, let's move on. So another thing, which is sort of natural to people coming from the functional background, is that everything or almost everything that can be an expression Kotlin is an expression. So you can return a value from an if, from a when, which is our version of switch case, from a try catch, although not everybody knows that. A return is itself a value of a special type, nothing, so on and so forth. Everything which is not a declaration or a loop is an expression. And I once had a conversation with Martin Udersky, who is the father of Scala. And I was curious why he thinks Scala is a functional language, because it's definitely not a pure functional language, but is positioned as a functional language. And I was like, Martin, so why do you call Scala a functional language? He's like, oh, that's very easy. Everything is an expression in Scala. If your language constructs are expressions, it's a functional language. And I'm like, good. Now I'm making a functional language too. Yeah, it's actually very convenient because many things can have natural semantics as expressions. Any questions about this slide? Okay. So taking many interesting things from Scala, we definitely had to leave many things out. And these are just a few examples. Like this syntax with lambdas yeah, this is a lambda actually, because if you put an underscore somewhere in Scala, the whole expression magically becomes a lambda, which you don't know where it starts and where it ends unless you know the syntax really well. So I got so scared by this that in Kotlin, all lambdas absolutely have curly braces, no exceptions. Also, Scala is big on custom operators like this or any kind of ASCII art you want. And this is how you define a setter for a property in Scala. We definitely didn't want any of that. Also, Scala's syntax for array access is unusual, and we figured out a way around it. So a lot of influence from Scala on the syntactic level, but many things we left out. Questions? Go ahead. Yeah. Sort of. So this is like a simple example. Yeah. So yeah, the question was, is this syntax so much more scarier than method references? Method references in Kotlin work with colon method name, and so the big difference is that this syntax, you can put an underscore like anywhere, and the whole thing becomes a lambda. And there are complex rules about how it works. And with method references, very straightforward. You just have 2 colons in the name, and that's it. So this is much, much easier. Anything else? Any more questions? Okay. So, and this is an illustration on how you make ideas from different languages work together. What language does this come from? It's definitely, I can tell you it's not Java, nor Scala, nor C#, because I'm creating a new instance here, but there is no new keyword. Any other language that does this? Python, good point. Yeah, val, of course, yeah, val is from Kotlin, but this is from Python. And we were looking at the grammar for Kotlin, and at some point we figured that we just didn't need the new keyword for any technical reason. In Java and C, C++, and in Scala, the new keyword is essential. It's not for semantical reasons, but for syntactical reasons. They're required to signify a constructor call. It's a meaningful operator. In Kotlin, new is not really needed. We can live without it. And it was kind of scary. Like, do you really need new for readability of your programs? Like everybody's used to having every allocation in the program being marked with an explicit operator. Is it bad if we remove it? It's definitely, it can be qualified as noise, but who knows? But fortunately, there is Python where there are no new keywords and everybody's happy. So we just went along with that, got some nice benefits on the side. Like now you can overload constructors in Kotlin with just plain functions. It doesn't have to be a constructor. It can be a function defined next to the class with the same name and some alternative set of parameters. So this worked. As a byproduct, to make it work, to make a Python-y syntax work in Kotlin, we had to do something alternative to how anonymous inner classes work in Java or Scala, where you say new base class, parentheses, and then curly braces in the body. So we had to invent something else to signify it's an anonymous class. And we use the object keyword that we're using in another context anyway, and saying it's an object of an anonymous class, which works fine. Any questions about this? Okay. So that's all about basic syntax, and the rest will be much more technical and hopefully more interesting to you. So we were coming from the Java background, and Java is an object-oriented language, meaning you can't do anything outside of a class, which in practice isn't great. And everybody learned that over the course of like 10 years of Java's popularity. And we definitely wanted top-level functions and top-level properties, and many languages have them. Of course, we had them as well. To be compatible with Java, and that was always a top-level requirement for Kotlin, we had to expose all those top-level things as statics in some class. So you have to be able to access them from Java. And if you want to customize that class's name, you can put an annotation on a file and get a custom name. Otherwise, you get some name automatically derived from the file name. So, and this is like the first step to get rid of statics. But there are many more interesting things about functions. And this is weird. So Kotlin has this type unit when you don't want to return anything interesting from your function. Now, why is it called unit? What do you think? Good mathematical training. Nice. Yeah, so unit obviously means one. It's like a unit of measurement. And technically, yeah. So the meaning of this is that all functions that just say return, don't return anything interesting, return the same object, one object that is global to the space of Kotlin. Oh. And technically, that object is a tuple of 0 elements, which is very algebraic. Yeah, but why don't we call this type void like Java does, or C, or C# for that matter? Because void means nothing, it means emptiness, right? And that type is inherently not empty. And we have an empty type, which means something completely different. So we have a type nothing, which means that the function didn't end correctly at all. So it didn't return anything. And this is an empty set. So there are no objects in this type. And we couldn't have nothing and void in the same language. It doesn't make sense. I would love to put nothing interesting here, but it's a little too long. So we just went, it was like a huge, difficult quest on finding a name. We didn't find any. We took one from Scala, and Scala is very academic. They like algebra, and they use unit, this like tuple of 0 elements there. So we're stuck with their name. Fortunately, a lot of the time we can omit it. And it's actually very important to have a type here, like in C and Java, this is not a type. Void by itself is not a type. Void's asterisk is a type, but void itself is not. And it makes the C type system for functions a little weird, because you can have a function that returns something, and a function that doesn't return anything is a completely different beast. It's very inconvenient. It's nice to have just function from no parameters to unit or int or anything else to be the same kind of thing. And it will be a function type of just 0 arity. So it's important to have a proper type there. But yeah, the names are completely weird, and this is how we ended up with them. Any questions? Okay, so the question is, what's the difference between int main and void main in C++? Int is a type, and void itself is not a type. You can define a variable of type void, for example. So if you type a function on C++, it's a function from no parameters to int, or from no parameters and without return type. These are two different things. And in Kotlin, any function has a return type. Sometimes it's unit, sometimes it's nothing. More questions? All right. And actually, in C++, it's more or less okay because they have function pointers. In Java, it's very bad because that is not a type, and it's very complex. I mean, you have to jump around it all the time. Okay, so next bit on functions will be extensions. And the idea of an extension function was around for ages. Groovy actually has a mechanism for adding methods to classes, but it's not so much of a static language. So these are examples from C# and Scala. So in Scala at the time, they have improved this thing quite a bit since then. But at the time in Scala, the extensions worked through implicit classes, which meant that whenever you have a person, you can call full name. It will create a rich person in place, an instance that will be thrown out right away. So it will just call full name and then throw this instance out, which is quite a bit of work for the virtual machine. Looked wasteful. In C#, you can actually define an extension method, but that, since C# also doesn't have top-level functions, that has to sit in a util class, and everybody's sick of util classes. The bad thing about this class is that it's a class that's not meant to be instantiated. So it's like a weird thing. It's only a bag of methods. So we sort of looked at all this and derived our own approach to extensions. But the motivation for this is what's important here. So people use extensions for many things. Like when you have a library that you don't have control over, you can add a method more or less to its API without changing its code. You can get rid of all those util classes. You can have nice code completion from the IDE, which is great. You cannot actually break encapsulation. No, it's not how it works. But the actual reason to have extensions, does anybody know what it is? It allows you to keep your APIs minimal. So think about string class in, say, Java or Scala. It's a class with loads and loads of methods, like many dozens of methods, because otherwise it's inconvenient. You want so many things on a string. In Kotlin, the string class has two members, length and a character at, that's it. And of course, this is not important because it's in the library anyway, but when you make your own interfaces, your own abstractions, you can keep them minimal in Kotlin because all the utility stuff you can keep as extensions. And then people that will manipulate your abstractions later don't have to deal with all the stuff you need as utilities. And that's the main reason why people have static extensions in languages. Questions? Okay. I hope this makes sense and I haven't lost everybody. So this is what extensions look like in Kotlin. This is the minimal interface for person. You don't have a full name method in the class. And this is the syntax that is just more or less symmetrical to the cold side. I figured it would be a good thing. Questions about the syntax? All right. It gets a more angle bracketly. So let's make sense of this. This is the initial syntax we had. So what this says is it's a function. Okay, there is a dot before the name. So it's an extension function on a list of A's. This function has two type parameters, A and B, and it takes as an argument a function from A to B, returns a list of B's. It's obviously a map, right? It just applies the function to every element in the list. So a few things are weird about this. One is that this A, where is it declared? Where? Here. Yeah. So this is the declaration of A, and this is the first usage to the left. It's weird. You don't do this. It's the parser doesn't care, but the human does, right? So this is the first thing that's not so great, and it's nice and symmetrical with the call side, but it's weird on the declaration side. And also, have I actually closed all the parentheses here? Are you lost around here? Well, people got lost all the time because this syntax, again, this function type looks exactly like a function declaration, but then at the end of the function declaration, you get confused by all the smiley faces. So this is how we fix it. Just put the declarations in front, that's nice and out of the way. And functions look more like in many other languages with arrows instead of return types. It's not symmetrical. So function types are suddenly a different syntax from functions, but it's so much more readable that it's worth it. Any questions about this decision? And here we basically went from like a generic duplication of syntax to something similar to what Scala has, but not exactly. They have a fat arrow here. This thing more or less comes from Java, because Java has all the declarations on the left. Okay. Another bit of syntax that comes from Groovy and is a very important thing to the entire Kotlin usability story is Dangling Lambdas. So if you want to pass a lambda to that function we just talked about, you say, okay, in parentheses, you have curly braces for a lambda, the parameter is e, and you say e.foo. And then here again, an e.bar. What's so bad about this? Well, many braces, you could have fewer, and the stupid name e, nobody cares about. So the way Scala treated it, I showed you, they have an underscore, which is magical. But Groovy had a very nice solution to this. You just have it. It's a name. It's actually not a keyword. It's just a name. You could have it, arrow, it.foo, and it would work. And in Groovy, the last lambda you're passing to a function can be passed outside the parentheses. You can have empty parentheses here, if you like, or you can have them around, but you can also not have them at all and put your function here. What it gives you is this kind of syntax when if you want to introduce your new block to the language, right? So this looks the same as while and if and all that, only lock is a function that takes foo as the first argument and a lambda as the second argument. So this is a very nice thing we took from Groovy, and it gave us something really precious, something like this. So in Groovy, you could define hierarchical declarative structures like HTML code with function names for tags and lambdas for bodies of the tags. It's all great in Groovy, but Kotlin is a statically typed language. So we had to figure out a way to type this correctly so that, for example, you couldn't put an A under HTML because A only belongs in body. How do you do that? You have to somehow drive the scope, like what kind of functions are available inside a body and not available inside HTML. Yeah, and this combines a few things. So these are functions. These are lambdas. So obviously there are function types in definitions of these functions. And these are just named arguments, of course. So there was one piece missing, which is not actually available in any language before Kotlin. And I'll illustrate it with this. So think about this boilerplate. You have to repeat the same name many times. Now think about the language Pascal. Who programmed in Pascal? Oh, quite a few people. It's actually Pascal is big in Netherlands. I can see because yesterday at the conference there was a lot of hands, and I started in Pascal, and it was this kind of with operator is a built-in thing in Pascal. You can just shorten your access expressions with this, but in Kotlin you can do this as a function in the library because you can do something like this. You can say that your with function takes a subject, your foo, and then takes an extension function as an argument. So this is a normal function of no parameters to unit, and this is an extension function to t that doesn't return anything interesting. So here in these curly braces, we have a this, which is our extension receiver, our t from there. And we can call this.bar, this.bar, this.cooks, or we could simply omit this, as we usually do. And here we go. Our builder syntax that can work with, can work with HTML and all that. alike. Questions about this? Oh, this is tough. Well, basically, it's purely aesthetical. So the convention, the way the convention goes, you put a space in front of a curly brace because this is the common practice in many languages. Now, the big question is, what if you have a single line lambda? Do you put a space after a curly brace? And people fight about this. There's like we have a guideline. I don't remember what it is, but people fight about this. Other questions? Okay. So this is actually an illustration of how adding a very small thing. So everything else was in there. There were functions, there were lambdas, there were function types, like normal function types. There was the syntax in Groovy. Everything was okay, but until we put extension function types and extension lambdas into the language, this thing couldn't work. And it was an explicit design requirement to support typed Groovy style builders. Okay, what language is this? Was it BASIC? Haskell with BASIC extension, interesting. Yeah, so it sort of looks like BASIC. It's actually Scala. And it's actually coming from Scala's documentation, official docs on the website. And this was meant to illustrate like how flexible and how powerful Scala's DSL capabilities are. And we looked at this and said, like, no way in hell we're having anything like this. So we have limited our DSL abilities quite a bit. We can do those typed builders. We can't do any new operators, like all the operators are hard-coded in the parser and you are not adding any new. You can have infix functions like print here. We can actually do a print. It's an infix function, but otherwise nothing else. And so this is Kotlin's approach to operator overloading, where if you want a plus on your A, you just say a dot plus, and then you can call it with a plus sign. You have to have the operator keyword in front. And also through the same idea of just having functions named properly, all other constructs in the language work. So if your for wants to iterate over something, you don't have an iterator interface for that. You have a convention. So if your foo's has a method called iterator, which can be of any type, but that type has a next and has next, fine, we can compile it as a loop. If one of these methods is missing, sorry, it's not loopable, over, that's it. And this idea actually comes from C#. So Java is all based on interfaces, and it's a pain in many situations, and especially it can be augmented with extensions, which is a problem, of course, for Kotlin's design. So we went after C#'s approach and had everything as just name conventions, so extensions can help. Questions? All right. Now it's going to be fun. So this slide shows something weird about Java and something else weird about Scala. So have a look. In Java, when we create a new instance of an array list, we say array list of foo, which is fine. But when we create an empty list, we say collections.of foo empty list. And I should put a Yoda here. This is weird. But then in Scala, you can say new list of foo, which is fine. And you say empty list of foo, which is also fine. But you have to say array of 0 with round parentheses, which is not traditional. And obviously, this is because the square brackets are used here. They're for types and not for values. And that's why you can put a 0 there. OK, so what's wrong with these people? And here, very smart people are working on these. So there is a reason. Any ideas? It's actually hard, but I'll help you. How many named functions are applied here? So plus is not a named function. Named functions are functions with actual character names. How many functions do you see here? 2. Any other options? 3. Okay, can you name the 3 functions? Bar, foo. X plus 1 is not a function name, right? It's an expression, x plus 1. Okay, more options. 1, which one? Foo. Okay, who else can see how it's only foo that is a function name here? Okay, I can help you. Have a look here. I made A and B smaller for you to see easier. You see, it's all the same characters, just exactly the same. But if here it was a foo of bar of types A and B and x plus 1, here it's foo of bar smaller than A, B greater than x plus 1. Ouch. This is where your parser gets confused. So for a person, because you're used to big letters being types, you know what you mean. But the parser doesn't care, right? So, and this is why Java and Scala have those weird things in their grammars, because if they put it the traditional way, it doesn't work. And it doesn't work like from the mathematical standpoint. It's called an ambiguous grammar. So if you want to describe it as a formal specification of a parser, it's necessarily ambiguous. So the parser doesn't know what to do. And so you're stuck with something weird, either in Java or in Scala, or if you're brave enough, or if you're C# or Kotlin, you just do this. So one important thing, there are no angle brackets on your keyboard. These are just less than and greater than, that's it. So you have to figure it out for yourself when it's one and the other. So what do we have in C# or Kotlin? This is how you create an array list. This is how you create an empty list. This is how you access an array. Everything's fine. And if you really want to make this a single function call, use parentheses. Otherwise, it will be parsed as a double function application. So the parser is, the grammar is ambiguous, but the parser is a program. We can tell it to prefer one of the options, and we did. So it prefers 2 types here. And if you really want something else, use parentheses. And no single user ever complained about this. So this is how very smart people here got beaten by mathematics, and some more pragmatic people just, hack the parser and everything works. Questions about this? Recursive descent, yeah, everybody does that. So it's actually quite interesting that the humanity created so much parser technology, like all the generations, like so much, so many tools, like Antler is very popular and there are many more, and nobody uses that. Like almost nobody in the world for any production language is using anything but a handwritten parser. Lexers are great, by the way. Lexers are generated. More questions? All right. Oh, jumped over something. Yeah. So that was syntax about generics. Actually, an interesting thing about generics is more substantial. So first of all, generics are a functional feature. They are not natural for an object-oriented language because it's the kind of polymorphism that is different from the object-oriented polymorphism. In object-oriented languages, you have overrides, dynamic binding, and you make polymorphic functions by just passing objects of subclasses. And in functional languages, it's all different. You don't have classes, you don't have inheritance, so you don't have a late binding. All you have is functions that can have types as parameters, and that's generics, basically, parametric polymorphism. So People in the mainstream languages made attempts at this a few times. C++ templates are horrible. Nobody wants that. Java and C# in their initial versions didn't have generics. The only generic type or family of types in Java is arrays, and they're weird because an array of object is a supertype of an array of string, which is wrong. It breaks at runtime. The same is copied to C#, and this is all because there were no generics. So you had to make this work somehow. There is no actual way around this. If you're having Java 1.0, you can't make arrays better than they are in Java. Came along a proposal from Martin Dursky that was called Pizza, and then later in Scala, there was a proposal of retrofitting generics onto existing Java ecosystem. So you take the class library as it was in Java 1, so with all the collection classes there, or in Java 1.3, actually, it doesn't matter, 1.4, you can do some magic, and those exact classes become generic. So all your lists and collections and maps get generics without any code that's depending on them broken. So all the clients are working, all the classes are generified, magic. So this is a huge power in this proposal. This is called erase generics. The price we have to pay for it is significant. So all the code that existed before generics were introduced has to work despite generics existing. So there are no type arguments in this code. So we have to somehow understand what does it mean to have a list of no angle brackets at all. And this is called raw types in Java. We still have them in the year 2022. They are not needed, but you can't throw them away because we're stuck with the old design decision. But they were the way to introduce generics without breaking all the code. C# went completely different way. They basically introduced a copy of their collections library in different package that had generics. And now every time you implement a collection in C#, you have to inherit from both old collections and new collections, which is weird, but it possibly not as weird as what Scala has, what Java has as a legacy to erase generics. Anyway, this is the way the Java ecosystem went. And we have erased generics and raw types in Kotlin as well. We have erased generics in Kotlin, yes, and raw types we could sort of sweep under the carpet. So the way it works in Kotlin is interesting because Java didn't take all of Martin Dursky's proposal. What Martin was proposing was this interesting way of retrofitting generics on top of the existing library, but also making some classes covariant and some contravariant. At the last minute, they didn't take this declaration state variance thing, and they went with this, which is super weird if you think about it. So if I want to copy something into a bag in Java, I have to say bag of super animal, because I may have an object here. I may have a bag of objects. It's okay to put animals into a bag of objects. So you say, I can take anything that's a super type of animal. And most users don't get this. And also, if you want to take something out of a bag, but you don't want this to be specifically a bag of animal, you want bag of anything like bag of cat or bag of dog, you have to say question mark extends animal. So it's not exactly animal, but any subtype of animal, which is super counterintuitive for most users. Since Java has it, we have to interoperate, and we have something that is in effect the same thing. So we have to support Java's use site variance, and we use C# style keywords for this. So it's a bag that only takes animals in, which makes a little more sense for practical purposes. So this is one thing, but also we wanted the nice way, of course. So this is how Scala does it, where you just say that the read is a class where you can only read t's from, and it plays nicely, so you can pass a read of cats where read of animals was expected, and write is something you can only put them in. So you can pass a write of supertype where its write of type is expected. In Kotlin, we kept the semantics, used C# keywords for it, and now we have both declaration and use state variance, which is unprecedented. So we had to come up with some mathematical solution to having both. We asked somebody from academia, Ross Tate from Cornell, helped us. And then we had to adapt his solution to real life. It's not as pretty as it was, but it works. Questions about this? Everybody's overwhelmed with generics. Generics are inherently hard. So yeah, this is what we have, mixed site variance. When in Java, you have to say list of question mark extends T, question mark super T. In Kotlin, list is already covariant, so you don't have to say anything. It just always this. And mutable list, you can say in T and be done with it. So it's much more concise. Okay, no questions. Okay. Yeah, go ahead. This? Okay. Mm-hmm. Yeah. Yep. Okay, so let's take it step by step. So first question that you're not asking, but it will illustrate things. What if I just leave out the in here? What happened? Leave out the in. It means that if my T is, say, string, I can't put a mutable list of objects here. Although it will accept objects, I will be only putting strings into it, which is fine. But the type system will refuse to do this because it doesn't know if I'll be taking out of this list. And if I will, I'll be pretending they're strings and they may not be strings. So this is why in is essential here. Next, so what you're asking, if I understood you correctly, I could put a bound here. I could say that T is a subtype of something. I could. Question is, subtype of what would you like? Okay, so I can have a T1 here and have a T as a subtype of T1. No. So here, if I say T is a subtype of animal, it's no, it's not the same, because here you put an upper bound in T, like it's what T is a subtype of, and there you're saying you want a super type of T. Yeah, so it's you'll need to play with it, but if you allow subtypes here, it can easily break. All right. Okay. Okay, let's talk about type safety. Yeah, so as you probably know, Kotlin has nullable types, and so basically a type string and string question mark are different things. In Kotlin, string question mark is where you have a null, so it's either string or null. Just string is only strings, no nulls. So if you return a nullable something from a function, you can't dereference it. So you can't say foo.bar because this may be null, and then it will be an exception. So Kotlin just prohibits this kind of call. But if you check that foo is not null, it's safe. So Kotlin allows a conditional, so a dereference inside a conditional, or you can check and return, and then we know that here it's already safe. Any questions about this? Sure. Scope for what? Here? Okay, it's semantical basically. So if you if you have a condition here, everything that's guarded by this condition, which is the body of if. So it's either the entire block here, if you have curlies, or just an expression here. And the same here. So if you return from here, all the control flow that goes after this return will be safe. So it actually does some primitive control flow analysis based on the syntax tree. More questions? Go ahead. Okay, good question. So what if my foo is not a val, but a var, and somebody can change it? So it depends. So if it's a local variable, we actually know all access points to it, and we can check if anybody can possibly change it between the check here and the reference here. If it's a global var, no way. We just do not allow this. You'll have to assign to a local variable and do this. Or I'll show you in other ways in the next slide. More questions? Yes, you can, and it will be treated as a possible assignment if there is an assignment in this closure. Yeah. Okay, so if you add this kind of functionality, you can't get away with just conditionals. You need some more operators to streamline the work with nulls. And obviously, we're not the first who dealt with nulls. We were the first to put them in the type system. So we looked at how people treat nulls in other languages that don't have types, nullable types, but have nullable operators. And these are very useful. So you can have a default value. So if this is null, it takes this, called an Elvis operator in Groovy. Also, it's a safe call. So if this is null, this doesn't execute. If it's not null, it executes and returns a value. So the combination of these two will give you like a chain of safe calls and default if the chain was terminated cut off early. What does this do? Yeah, it blows up. So if this is a null, this will just throw an exception. Why do you think it's 2 exclamation marks? Make sure it throws. Oh, so it's a 1, it maybe throws, and 2, it throws for sure. Okay, say it again. Yeah, it is. It's designed to stand out, to jump out at you, to be a loud syntax, because you're actually not supposed to do this a lot. Sometimes you need to do it, but it's a deliberately ugly syntax. And the same goes here. So casts are also discouraged in Kotlin. You're not supposed to cast a lot. And this is why casts are weirdly unergonomic to use. Questions about this? Double exclamation mark. If this is null, it blows up. It throws an exception. If it's not null, it's okay. Yes. Yeah. So it's basically it's a non-null assertion. Oh yeah. So this casts, and if it doesn't conform to the type, it throws an exception. And this, if it doesn't conform to the type, returns null. So why is there no exception? In the first one here? Yeah, it throws a different kind of exception. So it's ugly enough on its own, like this way, it's weird enough. It's actually an interesting idea to put an exclamation mark here. We didn't think about it. Yeah, but also exclamation marks and question marks are about nulls, and this is about just typecasts, which is different. So here we are casting to a non-null type, and this can be null if this evaluates correctly. It can be null, and this can be null because it's the default path for the cast. Nullable cast to nullable type, it means that you can't know on the receiving end why it is null. It could be null in the first place, or it could not cast. More questions? Null itself is a value, it's not a type. And if you want a type whose only inhabitant is null, what is it? No, unit is unit question mark has two inhabitants, the actual unit instance and null. Nothing question mark, correct. So you take an empty type, put a question mark on it, it contains only null. Yeah, with the union types. Yeah. Yeah, actually, Kotlin nullable types are union types by semantics, but we don't have arbitrary union types. They actually complicate the type system quite a bit. Type inference gets hairy with those. More questions? Okay. Checked exceptions. No, checked exceptions are a mistake in Java. Nobody else has checked exceptions for a reason. Oh, well, yeah, you can say that, but it's not really like you can't have a variable of a nullable type, right? Unless it's an exception variable. Yeah, it's more a confusing syntax. Like they have the same syntax for the multi-catch, but it's not real union types. More questions? Okay. So another thing that is big in Scala is pattern matching. Scala is a functional language, so it's big in algebraic data and on these things, where actually the important thing is this, and this are variable declarations, not references. So this is a variable defined elsewhere, but this is a variable defined right here and being assigned to. So pattern matching is very powerful. Many people like it. And most of those people are functional programmers or compiler programmers. And, you know, compiler programmers are my people, of course, and I have sympathy for them, but no way I'm having this in the language just for their sake. And that's why in Kotlin, we don't have fully fledged pattern matching, but we have something else. We have one expression is basically a switch case where you check X if it is a person, which is a runtime check for a type. Then you can access its fields as if it were a person. The same way you can dereference under a condition. Here we also have a condition, X is a person, so we can access its first name and last name. It's called a Smartcast. The compiler figures out a cast for you. You don't have to write it out in the code if it's sure to be safe. If X is a pet, you can go with a name, so on and so forth. So this is why the cast operator is so ugly in Kotlin. You're not supposed to write it explicitly because casts are figured out for you. And this is a deliberate design choice. So this is not pattern matching because you can't match on the structure. It's much weaker, but it covers 80% of the cases. Most people are happy enough with this. And another part of pattern matching is when you want a pair, you want to deconstruct it into two variables. This is how you do it in Kotlin. It works by convention. You don't have to be a pair class or a pair interface or something. If you have component 1 and component 2 functions defined on your type, they can be extensions. This is how you decompose into two variables. That's it. So this is as much pattern matching as we have in the language. And it's been fine so far. Say it again? Yeah, any number of components. You will only take 1 and 2. Yeah, but if you want 3 and it doesn't have the 3, it's a compiler. More questions? You can have 1, 2, and 4, but you can't assign it to anything over 2 components. Yeah. It's actually, I'm pretty sure you can't, but there was a new feature that came after me where you can skip components here with an underscore. But I think it won't type check. It shouldn't. More questions? Yeah. Yeah. Yeah, the question is, what about Java's pattern matching? Will Kotlin get pattern matching, but Java does? Well, the thing is, you're right. Brian Gutz really wants pattern matching in Java. I think it's not going to work. So when I was on the team, I was just waiting for Brian to roll it out and see if it actually happens in Java. If it does, we'll probably have to match it somehow. But I'm not sure it will ever gonna work. It's not that it's technically impossible, but there are many other challenges before that the Java team has to handle. So maybe it will be like 10 years out or something. And more questions? Okay. All right. I can actually stop here because this is already additional material. How are we doing in time? It's been over an hour already. Do you want more, or do we just do a Q&A and wrap up? Nobody's running away. Okay, let's do more. Fine. Let's talk about multiple inheritance. So the Java virtual machine handles all the heavy lifting, right? It handles all the method calls, all stuff that happens to classes, the declarations. All of that is going on in the runtime, and we couldn't alter this very much because we have to run over stock Java. And the way Java has it is you only have one superclass to your classes. You can inherit static fields and methods. There are static overrides in Java. Look it up. It's weird. You can have instance fields and instance methods. They can be public, protected, or package private. And you can inherit them if they are public, protected, or package private in the same package. Also, you can have multiple super interfaces. The order of super interface doesn't matter. So if I'm extending A and B or B and A, it doesn't matter. Static fields and methods can be inherited from interfaces. They can only be public. Instance methods can be inherited. They can only be public. And in Java 7, before Java 8, they could only be abstract. No fields, only methods, and only abstract. That's very limiting. You can't reuse many nice, useful pieces of code because in many situations, you want to extend a class and another class, or a class and an interface with some method bodies. For one thing, you don't want to implement all the methods in the interface all the time. And actually, this limitation on inheritance was quite pioneering in the early days of Java, but everybody got really tired of that. So people were looking for other solutions to the inheritance problem. And of course, there is always C++, where I have full multiple inheritance. In C++, you can have many superclasses. You can inherit anything, instance methods with bodies. You can inherit fields, and you can have constructors with parameters that initialize those fields. And to manage these constructors in a multiple inheritance hierarchy, you have virtual base classes, and no user ever understands how they work. I mean, unless you're really good at C++, you don't. So this is very complicated, and nobody wants the full power C++. So what do you do? Here is Scala's take on it. Let's make two kinds of things, classes and not interfaces, but traits. Trait is a nice word. People in computer science use it for something like a class, but not a class all the time. Nobody agrees on what a trait is. So Scala's traits, you can inherit from many of them. They can have instance methods with bodies, so you can inherit the bodies. You can have instance fields with initializers. So you can initialize those fields. You cannot have any constructor parameters. So your constructors are so implicitly there. They consist of the initializers, but no parameters are passed. And the supertype order matters. So extending from A and B and A, or two different things, because those initializers can have effects, and it does matter in which order those constructors are executed. So nicer than C++, no virtual base classes. And the gist of virtual base classes is if I pass parameters to my super constructor from a class, it doesn't have to end up with these parameters after all, which is weird. So in Scala, nothing like that, because no parameters, nothing is passed along the constructor chain. You just execute the initializers and only order matters there. So what we could do in the initial, very early version of Kotlin that was called the Jet language, we wanted full multiple inheritance, but on the JVM. So we wanted to be more powerful than Scala, but not as crazy as C++ somehow. And the runtime we were working on doesn't allow multiple inheritance. So what did we do? We had the idea that we'll have many superclasses and we'll always generate a class and interface for every class you declare, and actually another helper class too, so two classes and one interface, emulate inheritance through delegation, and it will work out magically. We'll figure out constructors somehow. Well, big surprise, you can't figure constructors out. Constructors are inherently messed up. This is a problem that has no better solution than C++. Forget about it. So this failed very miserably. After a few presentations, we figured out it's not going to work. And we had basically a choice, either go the Scala way or figure out something else. We went weaker than Scala because the ordering of constructors was pretty scary. People were struggling with the linearization algorithm that was used in Scala. So we decided no state. In the early Kotlin days, it was still called traits in Kotlin, but only method bodies, some compiler tricks in subclasses to make it work on the JVM, binary compatibility with separate compilation, everything works fine. Instance properties, but only computed ones, no backing fields, no state in the traits themselves, and great supertype order doesn't matter. Questions here? Okay, so, and sometime late in the game, Java 8 came about. And in Java 8, what they introduced to the language was lambdas. So it was the big change in Java 8. But with that change came default methods. So they basically added two things to the language and interfaces with bodies for some methods. Why do you think did they do that? They couldn't do without it. To meaningfully add lambdas to the language, they also had to add methods to collection interfaces, that took lambdas. And you can't add a method to an existing interface without breaking all the clients unless you have a body for that method. So they had to design the whole thing with method bodies and interfaces to retrofit lambdas onto collection interfaces. And we ended up basically with something very similar to what Kotlin has, interfaces with bodies in Java. So we renamed our traits to interfaces and migrated the underpinnings, and that was it. Any questions about this? Okay. Last bit, very sad story of companion objects. So as I mentioned before, nobody likes util classes. And like every big Java project has tons of util classes because there's no way around them. So one piece of getting rid of them is just having top-level functions, top-level properties, much nicer. You don't have a class around them that doesn't mean anything. But also, there are things that you want to put in a class to qualify the calls with the class name. So doing something like singleton.baz here. You want this in the language, but this is what statics are for, right? Statics are this foreign concept for an object-oriented language. Like a proper object-oriented language doesn't have statics. It has instance methods and instance fields, and that's it. So it was kind of a holy grail for language designers of different generations to get rid of statics. And we looked at Scala. Scala doesn't have statics, and they have objects, singletons, that are covering a lot of static functionality like this. Looks good, we took it. They also have something called companion objects, because if you want something static, not in an object, but in a class, in Scala, there is this convention that if in the same file, a class and an object have the same name, you can call the properties and methods of an object on that name, and it will figure out that you mean an object and not a class. So effectively, you end up with the same syntax like for statics in C# or Java, but it's divided into a class and an object. Correct. Yeah. If for example, here you have a convention for a function call, you can say data and in parentheses pass parameters to that function call. Yeah. And this is okay in terms of semantics, but the syntax we didn't like, because it's like you have to duplicate the name and they are kind of separated. This can be in the beginning of the file, this is at the end of the file, not so great. So we thought, okay, we'll take the idea, but we'll improve it a little bit. And this is how we improved it. So in a class, you can have a companion object. This is the essential part. So this is just the constructor declaration, never mind. Companion object. And guess what? Everybody hates it, because it's as bad as Scala, extra indentation. So it's kind of more logical in terms of scoping, but it's still bad. So my take on this is that we shouldn't have gone with companion objects at all. We should have had statics. Statics are fine. They're not like very nice mathematically, but they're okay. Pragmatically, we should have gone with statics and not with companion objects. But what's done is done. There was an interesting idea of having special kind of generic bounds. Like if you have a method that takes a t, you can specify that if this t has a companion object, this companion object can say extend this interface, which means that you can then access static methods on the t, which is kind of nice. We never got around to implementing this. And because it's just, some corner case, few people really need it. And so what we end up with is just bad syntax for statics. I hope one day people will introduce proper statics into Kotlin and drop companion objects altogether. Any questions? Why object? Because it's a single instance. So let's just go to the previous slide. It's the same semantically as this. So it's a single instance, a singleton, with it can extend interfaces and stuff. So it's a proper object associated with the class. So in this class, we have this companion object, single instance that's associated to it, which you can work with through the class name. And in Kotlin, you can actually customize its name. So you can put a name here. It's optional, but you can say my object foo, and then say data.foo. Whatever. More questions? Mm-hmm. Yeah. Mm-hmm. Mm-hmm. Correct. Yeah, and this is actually the reason why we didn't want this, because in Scala there is a privilege between these two. This guy can access this guy's privates and vice versa, which is weird scope-wise, right? So these are like friend classes, but there is no friend declaration. And in Kotlin, this is natural. So this guy can access privates from the outer class, and even the outer class can access its privates. More questions? All right. Yeah, and so to make things worse, to interop with Java properly, you sometimes want to expose this as a proper static. So you need patient there to make it work. Yeah, it was a bad decision. So 3 really bad ideas, I think, made it into Kotlin. Companion objects, inheritance by delegation. It's a leftover from this idea of multiple inheritance. You can, in Kotlin, you can say that I not only implement this interface, but I also, right there in the class header, I delegate all of its methods to this object, which is handy. The problem is this is a feature everybody wants improved, and it can't be improved. Like everybody wants access to this object, for example, and you have to create shitload of syntax just for the sake of that thing, and you don't want to. And you want, like many people want this object to be mutable, like to assign to it. And again, like a lot of syntax has to be created for it. And just for the sake of it, you don't want to add so much syntax to the language. So it's a trap feature, this one. And yeah, ternary if I told you about already. Questions here? Go ahead. Oh, ternary if, yeah, I didn't tell the story. So as I showed in the beginning of the presentation, all of the sensible things are expressions in Kotlin. If is an expression as well. So if we had if expression, if else, and ternary if, there would be 2 things for the same goal. And we just thought it was redundant. And like logically it is, but usability wise, everybody wants a ternary if. So I regret not having it. More questions? Oh, no, in C#, I don't think they have delegation there. They have, so delegates in C# are a completely different thing. So they have this interesting thing when you can say you can say that you override this specific method from a specific interface. And this is different. So it's like you don't override it in the entire method table, but just in that particular interface. It's not delegation. It's just you can fine tune your virtual table. Yeah, and I don't know of anything that's exactly delegation in C# actually. More questions? All right. Okay, so there are many other things I could tell you about, but it's already late. Platform types are actually very interesting, and it's magic we use to interop with Java nicely, because Java doesn't have nulls, it doesn't have mutable collections, it has weird things like raw types and stuff, and its arrays are weird, and all of this is not part of the Kotlin language, but you have to express it somehow to make type checking work. So we use something crazy called platform types. It's again, it was suggested by the same guy, Ross Tate from Cornell, but we had to adapt it to real life, and it's not as pretty as Ross suggested. Yeah, so that's an interesting story. I have a talk about it at the JVM Language Summit. You can find it on YouTube. Coroutines are a big thing for asynchronous programming in Kotlin. It was influenced by C#, first of all, async await there, and all the other languages that got async await after C#. And Go, of course, coroutines are a great thing. The way we did coroutines is quite interesting, quite unique in terms of how flexible it is. We have very little in the language and a lot in the library, so you basically can provide your own entire implementation of all asynchronous stuff. And the compiler only does very basic things for you. So I think this is a step forward in terms of state of the art in the mainstream programming languages. We also have types delegated properties. It's something kind of like what Python has, but with types. So it's also a step forward for typed mainstream languages. And we have inline functions. And you probably know that C and C++ have inline functions as well, but they have them as an optimization, and Kotlin has them as a language feature. So you can leverage the fact that your function will be 100% guaranteed inlined, and not only get rid of Lambda allocation, for example, but you can jump out of the Lambda control flow and make sure many other things work, like nullability checks and so on and so forth. So inline functions are also a step forward. Okay, so summary. We talked about many languages Kotlin learned from. There was a lot of mentions of Java, Scala, C#, a little less of Groovy and Python. I was trying to illustrate how ideas from different languages were put together and wired together to play nicely. They weren't initially designed to work together. And some of the common pitfalls we're trying to fix along the way. Sometimes it works well, sometimes it doesn't. But again, we tried. So, and once again, originality is for art, not for engineering. Use my ideas if you like them, and give credit. Be nice. Thank you so much for your attention. I can take all the questions you like. Everybody's tired. Good. The C style 4, yeah. Short circuit operation. Oh, why don't you like them? Oh, you mean the and or. Okay, I see. Yeah, it's okay to have a taste. So actually, it's an interesting question of like how much you want to differ from familiar languages. And few languages have these operators as words, and or and not. And many more languages have them as symbols. And it's a balance of like how much you want the users of existing languages to learn, or how nice you want to make your code. So with this particular thing, we went with familiar, with what comes from C and Java and C# and so on and so forth. But it's a forever debatable point if it was the right idea. I don't know. Yeah, more questions. Oh, no. Well, actually, it's an interesting thing. So we were quite opinionated in terms of how we organize design. So I very much admire the open communities that are pretending to design things together. In fact, they aren't, but they are going through a very extensive process of taking all the proposals and so on and so forth. They are doing great work. I can't. So Kotlin was designed at the whiteboard. Everybody was in the room. And so basically we had this, all the opinions were always listened to, and then arguments were given for this and that. And if something was not backed well enough by arguments from either side, it was just a voluntary choice on my part. So if we could argue to the point of decision, great. If there are pluses and minuses here and there, and there is no solution, obviously, well, it was my job to just make a decision and take the bullet, which I did a few times. Well, a few times not so well, you know. Yeah. Democracy is not great in designing complex systems now. You will probably never go to the moon like that. More questions? Okay, we didn't use any formal process, like no Scrum, no Kanban, no nothing. Yeah, but we did use agile practices quite a bit. So we used we didn't use much pair programming, but we used quick iterations, nightly builds, unit tests, code reviews with like sitting together at one computer doing code reviews, so on and so forth, and like stand-up meetings and many things from the agile paradigm, but no formal. And actually, the big thing about programming languages is that you can't do those nice quick iterations with a lot of users. So as soon as you get like a few hundred users, there's no way you're iterating every week, because people have to migrate their code. If you're changing something substantially in the language, people have to migrate their code. And so we still, for a programming language, we actually did an unprecedented thing in terms of iterations. We iterated very quickly, like every few months. And that was done through automated migrations, like we rolled out a new compiler and a set of automated transformations in the IDE that migrated all the code as well as we could possibly do it. So people could update their compiler version and the code and work like it was never a problem for them most of the time. And that made it possible to iterate like we had in the beginning. I had the slide with lots of milestones of Kotlin. Let me find it. Yeah, so here you can see that we went from M1 to M14, and those were iterations. So, and you can see that most of them are like a few months long. So this is very long, and this, I don't remember what happened here. But otherwise, they were public versions of compiler that we rolled out every few months for the users, and we get their feedback and fix things and so on and so forth. And we even managed to drop features after 1.0, which is also unprecedented. So Kotlin, I think many people in these teams learned a lot from Kotlin in terms of iterating the language, because we started extensively using experimental features. For example, other people did this before, but we pushed it like all the way. And now Java has experimental features, for example, which is a big step forward for them. So yeah, we did a lot of agile things, but no formal process. Yeah. Okay, yeah, I'll repeat the question. So the question is, all those nice automated migrations were available in the IntelliJ IDEA ID. What about all those people who didn't want to use it? All those 2 people were just out of luck. Yeah, actually, I think it was somewhat of a marketing-backed thing that most of our users were using JetBrains IDEs in the first place. And so there weren't many people using something else. Some people were using Vim and other agnostic editors, but really few people cared about any other like IDE setting. And for the Vim people, I don't think we provided anything. Again, you could load it into the IDE, migrate everything, and go back to Vim. But otherwise, yeah, we didn't hear many complaints about all that, because again, our crowd was mostly IDE people anyway. More questions? All right. Yeah, I guess it's a bit of a twofold question. So the question is, Java's legacy constrains some of the features. How much legacy is there in Kotlin? And I think it's 2 questions. So one is, how much Kotlin legacy is there in Kotlin? So some bad decisions that would drag along from the year 2010. And the answer here is a few, not too much, I think. So most of the things we have are not legacy. They're working fine. But I mentioned companion objects and delegation, inheritance by delegation. These are legacy things that we hate. There are a few legacy things in the library, mostly naming stuff like this. And those smaller things, and there are many language design things that are small enough that we deprecated them and dropped them and replaced them with something better. So over the years, you can say, okay, now we'll start reporting warnings on this thing, and we'll provide an automated migration. And a year from now, we'll completely deprecate it, turn it into an error, and then later we can use the syntax for something else. So this is what we do, and same for the library. And we have an extensive set of tools to deprecate things nicely in the library. And Kotlin is, again, quite powerful in this sense, because we put a lot of thought into this. And also, This goes for the new features, like when we introduce a new feature in a new compiler somewhere here, some people are still using a compiler from here. And if the library from here arrives to here, we need to complain sensibly. So we have this mechanism that's called messages from the future. So the newer compiler can write into a binary, can write a message for the old compiler so that it complains sensibly about what happened there. And this also mitigates many of the migration features and migration scenarios and so on and so forth. So regarding Kotlin Legacy, not so much. Java Legacy is definitely there on the JVM because it's on the JVM. So underneath Kotlin, we have still those arrays that are at runtime covariant. We can't do anything about it. We have a monitor in every object, which is weird and stupid. And it was a mistake in 1995 and nobody can fix it now. Java still doesn't have value types, for example. They're working on it. I hope they get it done. But again, today we can't return two things from a function unless we wrap it into an object, which is expensive. So on and so forth. So many things are still there for Java, and any Java language inherits it. So some can mask it with less performance. So Groovy can make things happen at the cost of like huge performance hits. We can't, and Scala can't. So you have to live with what you get. So yeah, it's a lot of Java legacy, and the Java team is working hard, but it's not easy to move such a huge thing, such a huge old thing forward. More questions? We did a few times. So basically, for a few years after 1.0, we went with feature-driven releases. Like we had a plan for the next release, and when the features are ready, we ship. And it didn't work too well. I mean, things got delayed and so on and so forth. People were complaining about not getting new versions of the language because some features were already ready, but stuck because of other features weren't ready and so on and so forth. So recently, like 2 years ago, we switched to time-driven releases, like release twice a year, no matter what features are ready, just release. And it's working more or less. So folks on the team have a release every roughly 6 months. So we still work a lot with experimental features, like new interesting things first ship they can ship in a small update as an experimental feature, and people play with them, we get feedback, fix, and so on and so forth. So yeah, so now the cadence is twice a year, like many other languages actually. Swift goes twice a year. C# now only has timely releases, and Java goes twice a year as well. More questions? Oh, this is complicated. Yeah, actually, all these marketing matters, like what you call your release, are purely marketing. And Kotlin, well, programming languages don't always follow the semantic versioning thing because we have this weird compatibility stance usually. So what you do normally when you release a new version of the language, you support all the old code. So everything that was written before will compile, and then you add some features. So something that's written in your new compiler may not compile with an old compiler. So this is like backward compatibility, and binary compatibility is even more strict. So many new binaries have to work in old environments because otherwise, if you update a library somewhere in a binary dependency, it can ship in somebody's application and not work because they have older Kotlin. This is bad. So now it's a question like, what do you call this next release of your language? Is it like 2.3 when you added some features and are backwards compatible to everything, or is it 3 actually? And as you probably know, many languages are kind of on the fence. So Java, for example, had actual versions like 1.4, 1.6, 1.7, 1.8 until they switched to proper 9, 10, 11, 12, so on and so forth. Swift has meaningful 1, 2, 3, so on, because they actually break compatibility. So Swift has a privilege of being Apple and being able to dictate everybody like, okay, your old code is not going to work anymore. Tough luck, people. And they break compatibility between these versions. C# doesn't do that most of the time. We don't do that. Java mostly doesn't do that. So for Kotlin, if we announce 2.0, it should mean something. It's like something big. And we are waiting for that big thing. Again, it's purely marketing decision because we're not going to break the old version anyway. So there is no like semantic meaning in updating the major version. But the rest of it is like when you decide that you're shipping something so big, you can actually call it 2.0. And my understanding is that the current idea is that when we have the new compiler, that's much faster and nicer in many other ways, this will be Kotlin 2. And it's around the corner. More questions? You know, it's a very personal thing. So when you work in something for 10 years, well, it can be different for different people. But for me, it was all the technical stuff that I could do there, I did. And all the new problems were similar to all the old problems. So engineering wise, I figured out how to do languages more or less, and I can do it well with my eyes closed and half asleep and all that. And it will be like world-class language design still, but it's there is little for me to develop in this personally in this area. So I felt like I could act more on my other strong sides and also do something not only for software developers, but for all people. So I switched to other projects that are not engineering. So that's one thing. And another thing is that I managed the team until it was 100 people or a little more. And that's tough. And I didn't learn management properly. I learned it the hard way. And I got really tired of that. It was very hard, but well, it all ended well in terms of I learned to delegate and got a few people on the management team. And when I left, it was actually 4 of us on the management committee. So it was easy to hand the project over to other people, but it took me like a lot of suffering to get to there. So yeah, it was a long journey, and I think I got everything I could from my work in Kotlin, and there are great people on the team that can do it well without me. I don't write so much code today, and my other project that I'm working on now is actually written in Python for historical reasons, because we started it right after Kotlin released, and it was too early to just hire programmers that could do Kotlin on the back end. So we did that in Python, and there is no interesting code in that project. It's just a web service. So I don't write much Kotlin today, but if I do any other large-scale project myself ever, I'll probably use Kotlin unless I have to do something CPU bound or something where Kotlin is not applicable. Mostly, yeah, it's Java and Kotlin, yeah. Oh, man, bootstrapping is so goddamn hard. Yeah, so it's like you can't really optimize for it. Bootstrapping is just a pain. So just for your understanding, so when you work on a compiler in the same language, the problems you have, you're using your compiler to compile itself. You're using an instance of a standard library that you rely on, right? So you have to first compile your standard library with the old compiler, then take that binary, compile your new compiler with that binary and the source of the new compiler. Then you have to recompile your library with a new compiler and try to redo everything to make sure nothing broke. And this breaks miserably in all possible ways, especially like imagine when you want to change something about the binary format. This is bad. And also, you know, you have all the integrations, the build tools, everything also depends on your compiler binary, and the IDE depends on that, and so on and so forth. This is bad. And also when you iterate on the compiler inside your team, you have to have everybody on the same nightly build of the compiler. If you didn't update, your code doesn't compile, or it does a different thing, which is worse. So, it's like we had to create some weird way of updating to Bootstrap builds for the team. And also, it's not like you could just pull an intermediate version of Kotlin and just build it from sources, because you don't have that Bootstrap compiler. So to actually recreate every build of Kotlin, you would need to go to the beginning of time and redo all the bootstraps. You can actually, probably you can cut off at the major releases because they are self-compiled. Well, actually, Milestone 14 had quite a bit of Kotlin in it already. Yeah, well, in any case. Yeah, so it's gonna be tough because you will need that very library version and the compiler version. Correct. Yeah. Correct. So yeah, it's pretty tough, but it's also important because you have to dog food everything. You have to dog food the library, the language, the ID, everything. So you have to work in your language on your daily things. So we could do the entire Kotlin compiler in Java, and we didn't want to because we wanted specifically a mixed Java Kotlin code base, because this was the use case we were working on. So we had to use it ourselves to make sure it works well. So yeah, it was quite a lot of pain. And fortunately, we already had continuous integration, and continuous integration makes bootstrapping so much easier. If you don't have continuous integration, I don't know how you solve bootstrapping in a team of 50 people. It's really hard. Yeah. More questions? 3-letter words. Oh, yeah. The most popular swear word in Russian, the word for dick, is a 3-letter word. More questions? Okay. Yeah. Yeah, Salem from Red Hat, yeah. Correct. Absolutely, yeah. Yeah, so the question is, around the year 2010, many other languages launched in parallel to Kotlin, and how Kotlin is different, and why didn't those languages take off as much as Kotlin did. So it's actually interesting. It wasn't so many languages. So Scala and Groovy already existed. And there were basically the two languages that you mentioned. There was a third language called Phantom. Yeah, so basically it was Ceylon from Gavin King at Red Hat. And there was Extend, which is, well, they didn't actually try to make it a proper programming language. It was a DSL inside their system, and it was a nice, interesting thing, but they didn't mean it to be, they didn't have a proper compiler. They compiled to source, so that couldn't fly from the beginning of it. And Phantom was an interesting multi-platform thing, but also in-house development from some company. They didn't really care to put it on the market. And there, oh, I don't remember the name. No, I'm not sure. It had a quite interesting design, actually. Phantom is an interesting language. There was also Gosso from another in-house development from some company, and they didn't really care to put it in the market anyway. So it was basically Scala, Groovy, Kotlin, and Ceylon. And the guys, well, Gavin King was very, very serious about Ceylon, but we all took very different approaches. So basically, Scala was the all-powerful language, like as powerful as you can make a language. They wanted it, like Scala is the language to write the Scala standard library, which is crazy smart. Not for average people. Ceylon was trying to do the whole thing from scratch. So they used the Java runtime, but they didn't want to use any of the Java libraries. And they had a poor interop with stock libraries. They could use them, but it was at some point they didn't have overloads, which is a no-go with Java and so on and so forth. And they also worked with the same guy I mentioned today, Ross Tate, and he came up with very nice things. And because of their approach, they could actually implement what he wanted, unlike Kotlin, where we took his overall ideas and had to hammer at them a lot to make them work in practice. And Ceylon, they did a greenfield thing with their own library standards and so on and so forth. So they could implement a lot of what he did. And those are great ideas, but nobody wants to start from scratch. Everybody wants a Java ecosystem. So I think this is why Ceylon didn't fly, but I'm not entirely sure. We were looking at Ceylon, and there was a very unfortunate incident in the very beginning, and Ceylon was announced. I subscribed to their mailing list, and they sent me their specification before releasing it. And Gavin was very angry at me for having looked at his specification, whatever. Yeah, so the thing is, there was one idea we took from Ceylon, and it didn't work. Yeah, so they had a very neat looking thing with, I wanted to unify annotations and modifiers. And this makes the IDE suffer. So we had to drop that. But otherwise, it was an interesting vision-driven language. But when I was at some point, we were sitting at the same table at some conference and was asking the guys on the team, how are you going to implement this thing that you have on the white paper? And I know it's not implementable. They're like, we'll figure something out. And of course they didn't. So, it was an interesting project, but again, greenfield things don't fly. And my take on Scala is that it's just too complicated for most people, and Groovy is dynamic and will never be full. So basically, Java and Kotlin are the reasonable technical solutions in this field, and Java is catching up, which is nice. I'm happy for all the Java users, but also with Android, Kotlin is very secure. Even if Java just outpaces us, Kotlin never goes away. And yeah, so we have nice two competing languages, very convenient bipartite thing. I'm happy about it. More questions? Okay. Could you clarify? Okay. Yeah. So why do we support so many use cases with Kotlin? Actually, it's an interesting question. So we could pass on some of the use cases. So some are essential to us, some are voluntary. So for example, we could not have Kotlin native altogether. So we could just stick to the existing virtual machines, only compile to the JVM or JVM and JavaScript. We could just skip on our own runtime. But there are appealing things, like when you already have your language, you've invested quite a lot and you want to make the most of it. And for both for the Kotlin community and for JetBrains as the vendor, it's very good to have many people. So as many use cases you can cover nicely, you will try to cover. So, and there are different answers to all your questions. So backend was the initial use case for Kotlin. There was virtually no Android year 2010. So we didn't know about Android. We targeted the Java population of the time, and that was mostly backend developers and also our own in-house desktop developers, because we had IDEs with lots and lots of Java code. So sometime, I think it was year 2013 or 2012, I don't remember exactly, and somebody came up to us and asked, like, does it work in Android? And I may have looked up Android at that point. I don't remember. But basically the answer was, well, it's Java, it should work, like try it out, we don't know. And maybe this person, maybe somebody else did try, and it failed. It failed in a weird way. So they sent us a core dump, like segmentation fault, something. They're like, what? Like, how do you crash a phone with a stock Java class file? It turned out it didn't crash the phone. It crashed way before getting to the phone. So Android, the way Android works, they use the Java, the language, and the class format and all that, and they translate the Java bytecodes to their own virtual machine. And this translator is called DEX, and it's a C program. So that program segfolded on Kotlin code. We didn't know why, and it's like, it's open source, but you know, core dump, you don't really diagnose anything. So we were already getting ourselves to like debug through this DEX thing, but somebody Googled this core dump, and fortunately Groovy already had this report and they fixed it. So we knew what the problem was from their bug tracker. And the problem was that DEX was actually sticking to the Java spec better than the JVM, the hotspot VM from Oracle. So they actually read the spec, and the Sun people back in the day, they implemented the VM and then wrote the spec, of course. So, and we put some flag on some class that was not supposed to be there. I think it was ACC static. Like in Java, classes can be marked static, but you can't put this flag in the class file. Or it could be super, I don't remember which ones it was. So DEX was not ready for that and just crashed because it didn't conform to the spec. And we had a few other roadblocks like this before we made Android work, but eventually we did. And actually all the Android tools cared about the Java spec more than the hotspot. So we used them in our test suites to make sure we generate valid bytecode. So we had that just integrated into our unit tests. So yeah, this is how Android came about. And the idea at the time was that Android is many new applications all the time. So from scratch projects, people are more likely to try a new language when they start from scratch. And it worked. And also they were stuck at Java 6 for a long time. So Java 8 was already released, but it wasn't available on Android. And people were like super unhappy about that. So Kotlin really did pick up there, and only a year after 1.0, we were already recognized by Google, which was a big thing. So this is how Android happened. And also we, pretty early on, I don't remember when, but I think somewhere around here, we realized that if we ever want to run Kotlin on any other platform than JVM, we need to start another compiler now, because otherwise the design will be too tied to the JVM. And we started an intern project, Kotlin.js, and it helped us a little bit to decouple the design from the JVM. Not everywhere we had to fix some things after the fact, but yeah, so this is how Kotlin.js started. And it was also like other languages were having this, like Scala had Scala.js probably already, so on and so forth. So it was like not something unthought of. And then there was a lot of talk about Kotlin native. Like, let's do Kotlin for embedded systems or Kotlin for Linux without any virtual machine, so on and so forth. And we were like putting it away for years. And then just the right person came looking for a job, and we hired him and started Kotlin native. So yeah, so this is how we basically seized the opportunity, because it was pretty clear that there is a space where Java is not an option because it's like too heavy and too big and so on and so forth. So we wanted something, and we did a crazy experiment with Kotlin native with a completely different memory management system, which failed. And the team is now rewriting everything to a normal tracing garbage collector. But still, so Kotlin native is a thing on Apple phones, and people are doing multi-platform between different phones, which is a big thing. And people currently people mostly suffer, but still do it because it is beneficial for them. But in a few years, they will actually enjoy it. So yeah, that's why. More questions? No more questions. Okay, nice. Thank you so much.